What's the first thing we do when we go and turn them on? What do we do?
Spray water.
Make sure this is backed off and loose. In the old days, it'd come flying out of there. So first thing we do is make sure these are backed off. Which one do we turn on first? It don't matter. It don't matter which cylinder you turn on first. And then what do? You turn them on one full turn max all the way, right? Okay. How much settling we use? This is
15.
this is a bleeder.
I think like 13. Isn't it like 13?
Got tip cleaner? As that movie with Tom Hanks is in there, I have created fire.
I have made fire.
See this? We lit the torch. We got a flame. That gets shorter. Why? Because we have turbulence in and around the tip. Turbulence produces hard slag. I don't like to grind. Thanks, sir. So if I can save this real quick, I'll pass a wire through it one time. You don't want to waller out a tip. You just want to run it in there straight. And really, one time is all it takes. I pick a wire that has just a little bit of resistance and try to run it in there straight and pull it back out. I have taken pride in doing precision cutting with a burn bar or straight edge and get ready to cut, and about the time you get ready to cut, you check it one more time, you got a piece of mill scale that's flipped up there. Why does it always get right next to your cutting orifice? So anybody answer that? Anybody got a dime? Give me a dime. Okay, that's better. You see, hey, you see that dark blue line going through there? That's my oxygen jet. That's what I want. Actually, I like it to be out further than that, but you hear that ripping and snorting? That's what I really want. Is it possible to pick this dime up? What the hell's going on there? That's how you get that speck of hot mill scale flips up there, and it'll create turbulence around your cut. Turbulence, you're gonna be acquainted with your grinder. Trust me. Here's your dime back. It ain't hot, I don't think.
Eduardo, thanks for...
Thank you, I appreciate that. Usually I put that in my pocket.
Need a clamp or not clamp?
I hope I don't. If I need to clamp, I'm a nervous individual. So I want to bevel these for him. I want to get him a fit up. There's how many preheat fingers in the flame? How many preheat fingers are in this torch flame? Like 5. You do your layout, you can set one of the preheat fingers down on your scribe mark and be extremely accurate. Am I preheating this so I can cheat? Good, right. But see that liquid coming off there leaning forward? Somebody get that, please. Smooth along here. That's not coming off. Let me see if I can get smooth here. Well, I got nothing to grab a hold of here. I don't have my pliers. Anybody got pliers? The whole point is this flag that's on here, the flag that's on there most of the time come right off. Not me, man, you. That coupon cooler. That should fall right off. It'll cut better if you remove the mill scale, right? It'll cut better if you move the mill scale. True or false? Mill scale melts at a higher temperature than the parent metal, than the steel. Is that true or false? Anybody? False. No? One more time. Mill scale melts at a higher temperature than the parent metal. Do I need to say that again? Nobody. Just say yes and get it over with. Yes, sir. It does. So therefore, that's why you get some of your hard slag conditions. Clean that mill scale off, it cuts way better. Way better. A lot smoother. Has anybody been cutting along and you hear a whistle? Hear that whistling sound? That cut condition doesn't get any better. You're not going to be grinding slag when you're done. Anybody been to a Skills USA competition? Anybody been in a cutting competition? Bevel anything? Do yourself a favor and let the person that you're competing with go first. They just preheated the material for you. Why not? They make a pretty good cut, and then you walk in behind and make a glass cut. It's primo, and they go, dang, I wish I could cut like that. Cut like that every time if you go first. And you just preheated the material for me. I appreciate it. Yeah. Now let's see if we can do something a little better. Maybe not. Isn't that what we're after? Isn't that what we're after? I mean, you can do straight edge, clean cut, just like your tractor. You're doing the same thing as a tractor. It's doing it manually. And if I had something up here, like a piece of angle that I could put my middle, I'm sorry, I hate it when it does that. But if you could do that, then I could be pretty steady and smooth. So for fit up, you know, if you did a couple of these bevels for fit up like that, that's a long cut. I was holding my breath the whole way. So, I mean, the point is, you know, if you get the right tooling in your hands, whatever you're used to working with, we're not grinding a whole lot. I mean, it'd take very little time to rake that off with the flapper disc, take it to your coupon cooler first, but knock the mill scale off the back, dress the face of it, and you're done.
I mean, you want to compare would you want to compare your cut to what the beveler can do? Just to see the comparative difference to what the nibbler can do to compare to there?
Yeah,
because that's actually less edge dressing than the beveler itself has to do.
Yeah, but that thing's fast. I mean, it doesn't take the expense of the oxyacetylene. So there's benefits of both.
But by the time you get into edge cleanup, which one's a little cleaner, which one's a little easier?
I mean, yeah, it's got some marks in it, but gee whiz. So if we did, here's a poor man's bevel right here. If we clean this face, if we clean the mill scale, and put them both back to back at 90 degrees and put a little gap in there, that's the same thing as a bevel, is it not? I mean, we can do those a lot. I just don't like wasting material. I would take these after they're done with them and fill up this entire, just fill them up. I'll see you tomorrow. That's your assignment, you know. That's a lot of rod burning. Straight line, straight height, blend them together correctly, same width. If you mess one up, go grind it out. Teach you how to run your grinder too. Yeah? Learn anything? That demo was free, by the way. I ain't gonna let you pay for it. Uphill, downhill? What?
We go up. We ain't got 80 time.
That's some odd running 60-10. Thin bladed grinder is what I need. Rip that out. A little inconsistent there, gents. Had a hard time punching through for a little bit. Thin bladed grinder?
You prefer your electrode pointed down a little?
I do. I do.
Okay.
On almost everything, especially when I do this cap. So let's go to 135. 135.
Jeez.
Yeah, I know, but I got to get down through this thing. I just plan on leaving this thing flat and below. Ready? Good. So I've left it. I blew a lot of crap out of there. Granted, I'm not doing this for a bend test or anything. I probably could, but
For sure.
it's flat and it's flat and slightly concave, and I didn't get into my edges. Those edges are my guide when I put my cap in.
Yeah, I explain to my students, a lot of those are like the yellow painted lines to tell you where your road is. Like, what
Yeah,
lane
I
to
mean,
stay in.
I got to see those edges down below the rod. 5 or 10% on the arc force. Take it out of there and give me 85 amps.
So you want 85 amps, and what do you want?
Yeah, I think.
Are you doing that just to help you see your negative?
No, I'm doing it to get the dingleberry huevos off of there. I wanted to plate flat. Need to tell some jokes here. Let this thing cool off, or break it off, and cool it. Yeah, I would like to cool it, but
We get a quench tank right there.
nah, I'll do it hot. So, what's the one thing that we do not want to leave behind? We want to establish our cap. What's the one thing we don't want to leave behind? Undercut. Undercut's the killer. You could have it. You could have your reinforcement, which is weld metal above the parent metal. You could have your reinforcement, but if you got undercut, you just lost. No good. Okay, so we don't want to leave behind. That's why I'm trying to see these edges well. I've learned something here. On some grades of piping, you'd be welding along, and even on some grades of plate, you'd be welding along, you think, God dang, that weld's going to look good. Got a little bit of undercut alongside of it. If you can feel it, if you get to know your machine well enough, when you weave to the side, and I'm one to hold a short arc. I used to say short, steady arc, but there's nothing steady about that. It ain't funny. If you come across here, you can do a little tuck. Just barely a little tuck. If you can do that, you're going to be golden. You're going to win a lot of competitions doing that. You're not going to be leaving undercut behind. Ask me why I bend this, so I can get about any angle. That's all it is. I try not to force a bad angle when I'm coming in here with my hand. I always want the same rod angle. I want to be able to treat it the same, straight in. Okay. These plates are too hot. I Hey, don't do that. What's this? Yep, it is. Do we have undercut? Well, we better not. We got it up above the plate. That's a little bit of light slag, I hope. Anyway, get to know your equipment. That's where you're at with it. That thing runs hot on the cab and weak on the root. What's going on with that? Anyway, repairs. If I need to get back, what? If I needed to repair that, I'd go in there with a thin bladed grinder. I'd probably grab the next size smaller 6010 and punch it through. Is that allowed? Hell yeah, it is. Pay attention to some of your codes and your procedures. I could run an uphill route, downhill hot pass, and it'd be approved. I don't want to run downhill 7018, obviously. You know, you could run downhill route, downhill hot pass, uphill 7018. You could write a procedure for that. It's okay. What you don't have is pre-approved procedures for gas metal arc welding stuff, short arc.
Sure.
So you're gonna see I'm left. You want to turn that over, turn it around, or here? You want a prop? Is that gonna give you enough prop?
I'll figure it out.
I know you will. Hey, don't be making the weld better than mine now.
Uh-oh.
I know he will, and that's good. I want him to. Have a second longer on the side. Stay in the pool. Didn't say weave wider, just say half a second longer. You're long arcing a little bit. You're all right though. You're good. Do you tend to leave undercut on your welds or underfill at times? You can talk while you're welding, it's okay. Do you tend to leave undercut at times? I can see why. You undercut just a little bit, and you long arc just a little bit. And the timing on the sides. You're weaving outside the groove on the right hand side and not on the left, I think. See, here's the tendency. Here's the tendency. Which way does your body naturally go? It points in like this, right? For the left hand, but you're just the opposite. So you're pulling it over here with your whole arm, which is fine, but you know, pay attention to that arc length, where the electrode is, and how much time. You got to look underneath the rod. Don't look at the arc. The arc's up there dancing around, doing all that good stuff. Don't look at it. Look at the weld pool down below the rod. That's what you're controlling. And by the way, you're in control. You know. You got to ask yourself, who's in control? Is that weld going to own you, or are you in control? See, you want to be confident, step up to that. Weld better than I do. Get the out of here, man. I just got whipped. But spend just a little bit more time so you don't undercut. And that arc length, you know what, your weld pool, everything would get just a little bit darker if you decrease your arc length just a little bit. Oh, y'all ain't over here slapping hands, are you? Come on.
Let me finish this.
Beat the old man, they got to celebrate. What's up with that?
Competition out here in the competition, you call it.
Yeah,
What is that? See, anything is a shadow. Anything's a shadow is undercut.
Yeah.
Slap hands. No, I'm kidding. See, that's what you want to avoid. Because if you go to take a sample out of that coupon, and you bend it, you're only allowed to grind down to the parent metal thickness, and that's it. You can't reduce it till it disappears. So if you go to bend that, where's it going to? It might tear, it might open up, and then if you read the codes, you're only allowed a certain amount. That's the thing. Read the codes and see what you're allowed to get away with, and then work within that window. It's not cheating. It's knowing where you're at. You know. You have to overcome everything all the time. Every time you drop the hood, you're overcoming a problem. You got to solve the problem every time. So I'm solving the problem underneath here. I'm whining, crying like a little baby because I'm not getting the output that I'm used to getting on the. Well, I'll get used to it. I'll turn and burn, but first time I was on the machine. Every machine has some characteristic to it. I have literally purchased machines that have successive serial numbers in manufacturing. I can assure you these two machines run different somehow. It's like buying two Ford Mustangs. You know, hers runs hotter than mine. I'm getting whipped. They came off the assembly line one after another. What They're machines. It has to be that way, you know. Got some edges up here. Might as well take care of them, you know, or try to.
Clean them up, dress them up.
Should have put the gap in them, but it didn't. I got nervous and didn't put it in there, you know. No, I just getting lazy. Looks like it. he knows what I'm talking about back there. He knows old time Chicago. Huh? What? What?
I like it.
Everybody asks me, why you point the wire downhill? Well, I want it on fresh metal. I don't want to be riding on top of my deposited metal when I'm trying to do field pass. I didn't get into this initially on my route. I'm trying to make the repair for you, okay? So I'm trying to get back to 100% pin. Now, I'm fairly good up here, but I need to feather this up here so that when I fall back down into this, and there's uphill procedures as well, okay? But for speed, I'm just trying to get this one done. I really need to get these shavings out of here. Inspectors don't like to see straight razor blades on an X-ray, okay? You wanna feather this and feather this. If you don't, your gas metal arc welding MIG root is gonna look like it bumped up again there. It's gonna leave a void in there, can't fuse in. If you thin it out and feather it correctly, it can blend in there. I'm not comfortable with that. I like a way wider gap than that, and that's what I didn't do to begin with. That's why I left what I left, okay? Turning up the values is not gonna get it penetration. You can turn that up to globular and run it in there super hot. It's not going to give you the penetration. It's in material prep and fit up, is it not? It's in material prep, right? So I'm where I was for the root. I don't want to change anything. Make these welds, root, uphill, fill, pass, and cap all the same. Hey, somebody asked me, nobody answered me, how come the H4R was on that rod over there? Anybody answer that yet? What was that? Hello. Hello, grind mode. How are you doing? How are you doing today? I welded the majority of my career at number 9 gold glass. Number 9 gold glass. Can't find them anymore. And for a long time, auto darks, when they weren't fast enough. They just didn't keep up. I could make a tack and be done before this thing decided to get real, you know. There's been some really good lenses here lately come about. If you're feathering something in and you tie into the bead, keep going past it. Don't just stop. So I broke the edges down there. I don't know if it's concave or what. It is concave. Anyway, I didn't have a root face on there. When you're making a repair, last thing you want to do is just shove the grinding wheel right through there. You'll have 2 thick root faces on there, and that's counterproductive. Okay, so that was the root, a repair. I sucked back a little bit. The plates are too damn hot. We're trying to rush through this. So now I have this in here for a cap that's left. I need to clean the deposits off of it, but if you'll look at the deposits, where are they? The deposits are in the center. They're easy to get to, okay? I was a fitter one morning in the Conoco R&D facilities, and I've been using this 1/8 inch blade all morning long. I didn't use it incorrectly at any given time. I'm grinding out a root pass and the thing explodes. Operator comes over and says, "Are you okay?" And I said, "Yeah, I was shutting everything down, unplugging." I had my face shield on, work shirt, all that stuff. He goes, "You better go check your face." It looked like somebody hit me with a bullwhip right below my eye, all the way down here. How'd it get there? My face shield was down. I'm like this. It's up against my work shirt. How'd it get there? Don't take that half second in time for granted. Wear your safety gear, wear your safety glasses, Pay attention to what's going on. Don't cut corners. Chances are it'll do something. That half second of time will change your life forever. Okay? You don't want it to be your eyesight or anything else. I've been using the thing correctly all morning long. All of a sudden it decided to explode. Listen. Did you hear a tone change at any given time? Did you hear a tone change like when I was on the sides? You weren't paying attention because the machine is telling you when to move. The weld is telling you when to move if you're paying attention. Seriously. I could probably tighten that up a little bit by decreasing voltage, making it a little bit crispy. You know? Some machines, I mean, some weldments that fit up and everything, if you listen closely and pay attention, it'll tell you when to move over. It says, I'm full. When it's full, the wire's now on top of the pool, you know what I'm saying? And there's a tone change. Pay attention and it's easy. Am I leaving undercut? I hate it. No, I'm not. Okay? I hate undercut. Some machines, I mean, this one sounds a little, it's a little wet, you know, but that's okay, it's fine. I'm not weaving outside the groove. When I was growing up and reading the textbooks, it was the books and the procedures or the movements and all that crap. They'd tell you to move like this. They'd tell you to move in the U. That'll get you in trouble every time. What they should have been telling me and what I figured out after a while, after making a bunch of bad welds, it's upside down. Upside down, pause, inside the groove, pause, inside the groove, pause. Watch the weld metal wash around the edge. It creates the reinforcement, doesn't leave any undercut. Clean every time, gentlemen. Clean every time. Made thousands of x-ray quality welds on boilers. Not like this, that's undercut. You know why? Gravity sucks.
Yep.
If we fall, we get hurt because we're allergic to gravity. Actually, we're allergic to sudden stops. I can go on and on forever, but pay attention to what the weld pool is doing. You're in control of it. You know, I read the wrong thing for a while. It just, why'd they tell me that when I need to be doing something different? Didn't we learn kind of the hard way? Jeez, I wish I had that information elsewhere. You guys can do better than this easily. Yeah, you can do better than this easily. I'm just showing you a few tricks and tips and stuff. It's all good. Working with the man on his machine here. I'm coming back. I ain't going to accept defeat, you know. Questions? By the way, that H4R is hydrogen diffusion. You can leave that rod out all night long in the rain and you weld with it the next day. It won't bleed hydrogen, believe it or not. A 6010, you don't bake them. It don't matter what you do, they're going to bleed hydrogen. They'll bleed hydrogen. You take a sample, just weld on a piece of plate, put it in mineral oil in a Pyrex dish, put it in mineral oil. You see all these bubbles coming off of it. On a cellulose rod, all them boils bubbling in, that's hydrogen. Take it with a low hydrogen rod, 7018, do the same thing. You'll see maybe 1 or 2 come off there in mineral oil. Nice hood, homie.